Hey, I'm Cody, and I'm going to go through this Bitcoin Core 0.28 new features guide that I put together with the help of Greg and some of the other Optech guys. With the Bitcoin Core 0.28 release, we got the first pass at package relay. And so this REPL is set up where you can just download Bitcoin 28. And if you want to do that, you just check the just file. You do just download Bitcoin. And that'll run a script that will download the 0.28 release from bitcoincore.org and then put it into the Bitcoin 28. And then we're going to also source the env.sh. So we're going to go source script /env. Yep. Okay, so now it's loaded. So then if we do Bitcoin D version, there we go. You can see that Bitcoin D28 is installed. Cool, so let's go back to the tutorial. That was setting up the environment. The REPL should be already configured for when you fork it, but you can also run it locally if you want, and just you can use the Nixflake, or you can just run exactly what I did, where it just uses bash scripts. And then if you also want to download Bitcoin Core 27 and run through it, just see the differences and see that the package relay doesn't work with 27. I thought that was interesting to run through as well. But when you source the environment script, then it will set Bitcoin CLI to be the 0.28, and then Bitcoin D to be 28. And then if you hit run from on the big button here, it will just start the reg test Bitcoin D. And so we can see here, Bitcoin CLI-reg test. Let's do help. There we go. You can see that it's connected and it just lists all those things. We can do get blockchain info. You can see that it's connected to this Bitcoin D that's running locally. Okay, so let's get started. So the first feature in 0.28 is one parent, one child relay. And so prior to Bitcoin Core 0.28, every transaction had to meet or exceed the local node's dynamic mempool minimum fee rate in order to enter the mempool. And so the fees go up or down depending on like what's happening around the rest of the network. And so if you're trying to do something with like pre-signed transactions for like a vaulting structure, where you've got a bunch of pre-signed transactions, you're like, oh, hey, I want to move a bunch of this stuff from the cold wallet into the hot wallet if you're an exchange. Or this is a huge issue if you've got Lightning transactions, where the thing that you're holding on to that you want to do a force close with, for example, is a pre-signed transaction that has a fee rate that's pretty low. That might be pretty low. If the fees spike and then you don't renegotiate that one, then your transaction might not get included. And so one parent, one child relay allows you to submit a package. So the first parent transaction has a low fee rate. You can submit it with a child that has a high fee rate that will pay for the parent, and you'll submit it both of them. So even though the parent is below the minimum fee rate or the minimum relay transaction fee, then it'll still be included. All right, so let's go run through and test this out. And there's a bunch more details over here about it, but let's actually just see this in practice. So first thing we're going to do is create a wallet. It says create wallet test. There, and then we're going to create a address from this wallet. There we go. And then we're going to generate some coins. So this is just mining to myself. Sorry. There we go. And then these are the block hashes that mine there. And then if we do Bitcoin CLI -reg test -BC wallet equals test, and we do list unspent, you can see that I have one Coinbase output available here, and it has 101 confirmations. And if you're wondering, the reason why is because it requires 100 confirmations in order for a coin to be spendable from a Coinbase output. Right, so of the 101 blocks that I mined to myself, only one of them is spendable right now, right? So this is the one that we're going to use. Okay, so let's keep going down. Let's get mempool info. CLI dash test get mempool info. And here we go. Just says like the fee rate. There's like no fees in here, but we can see that the min mempool fee is that's like 1,000 sats, and min relay transaction fee 1,000 sats here. So for old school transactions, you have to have a fee rate for this one. And then what we're going to do here is we're going to do a 0 fee parent, and then we're going to attach fees to the child, and then we're going to send both of them as a package. And we'll see that even though the parent has 0 fee associated with it, it'll still be able to submit to the mempool because the child contains fees and it's evaluated as a package. Right, so let's go in here. Let's create the parent transaction. So the first one, we're going to do Bitcoin CLI reg test, create raw transaction, and then we have to build out which coin we're going to spend. So we're going to do TXID is this guy. Be out 0. And then I'm just going to have it paying to one of my addresses that I just generated. Have it pay to this guy. And the amount is going to be, let's do 50, right? So that's the full amount of the UTXO. So here, should be able to hit enter, and then here we go. So this is the transaction that we have, and then if we decode this, decode raw transaction, you can see that there is one input, one output, and it pays the full value. And so there are no fees associated with this right now. Right? So let's do this. We'll go, we're gonna switch this to a V3 transaction. And so that's the new transaction format. Sorry, the new transaction type that allows me to do a 0 fee transaction. You can see here it's now version 3. And we're going to try signing that. BC wallet equals test sign raw transaction with wallet. Cool. Okay, so we signed it, and here we go. If we try to send it, then we can do Bitcoin CLI dash reg test send raw transaction. Here we go. You can see we get min relay fee not met yet less than 110 sats. So the min relay fee for this is now 110 sats for my reg test node. So how are we going to fix this? So what we're going to do is we're going to create a child transaction that's spending the output from this guy, and that one is going to have some fat fees on it. And then we're going to take both of these transactions and we're going to send them. And so they'll be evaluated as a package, so that even though this first transaction doesn't have fees, the miner will still be, the mempool will still be willing to accept it because the child that pays out of this has enough fees for both of them. So let's do this. So first we have to decode this transaction so that I can figure out what the output's going to be. Decode raw transaction. Cool. So this is what the V out is going to look like. And then this one, so it's just one output, so V out's going to be 0. And the transaction ID of this parent transaction is right here. Right? So here, we're going to create the child transaction now. CLI dash reg test, create raw transaction. So it's going to be this parent transaction as the input. And V out was 0. And then for this one, we'll have it sending to that second address that I generated, which was over here. And for this one, we'll do 49.999.000. Okay, so this one's got 1,000 sats in fees on it, and so that'll be enough to pay for both of the parent and the child. So here, let's close this one out. It's because I did not close this properly. Oh, sorry. Has to be a comma there. And then, it's because I have to do TXID. This guy does not have the bracket. There we go. Okay, so this is the child transaction. So we're going to sign that. And when we sign it, our wallet thinks that it's signing something that doesn't exist yet. And so when we do the sign raw transaction with wallet, we're actually going to have to provide information about the parent transaction. This is TechRPC wallet equals test. Sign raw transaction with wallet. This guy. So if I just try this right now, it'll say that it doesn't exist. Right? So input not found or already spent. Right? So I have to provide it the information, and I need to change that to a 0.3 as well for the transaction. We're using 0.3 types. There we go. Okay, so now I have to provide the information about the parent. And so for this guy, do TXID, the parent TXID, which in this case is this. The V out of that one was 0. The script pub key, which is the spending condition of that output, is this hex, because this is the output that I'm spending, that the output that doesn't exist yet that I'm spending. So I have to tell it about that. And then I have to say what the amount was, and the amount in this case is 50. Okay. Okay, now this one should work. Sweet. Okay, so this signed the child transaction, right? So now if we try to just send the child transaction, it's not going to accept it. Send raw transaction. There we go, right? So bad transactions, inputs missing or spent, right? Because the child is trying to spend some Bitcoin that doesn't exist yet because the parent transaction hasn't gone through, right? So I have a parent transaction with no fees. I have a child transaction that can't be sent without respect for the parent. So how do we fix this? Is package relay. So I'm going to package both of these and send them out at the same time. So this is the new command with Bitcoin 28. Here we're going to do wallet equals test. We're going to do submit package, and then I'm going to put in the parent transactions information, which is this guy. So we're sending the parent and we're sending the child. Then I click enter, and we can see that the package message was a success. So the transaction results are that both of these transactions went through, and the effective fee rate for the base fee for this guy was 0. The base fee for this child was 10,000 sats. Oh, I thought I was doing 1,000 sats. It's all good. The effective fee rate for both of these guys, right, is like split for that, right? And we can see that since the effective fee rate for both for both these transactions was higher than what it was set for the mempool accepted this. So now we can go see that this is accepted in the mempool. And there you have it, right? So we can see that both these transactions are in the mempool, right? And the total fees is the 10,000 sats that I put in there. Okay, so now what we're going to do is we're going to try to bump the parent out of the mempool and see that it fails because the package fee rate's higher, right? So with normal replace by fee transactions, I should be able to replace the parent with a higher fee rate transaction. And then, but because with 0.28, we're thinking of them as packages, that normal replace by fee is just not going to work, right? So let's go on to that. Here we go. So we're looking at the mempool, and it's got these two transactions in it, right? So this guy was the parent, and this guy was the child. So now we're going to create a new parent that conflicts with this guy. So let's go here, Bitcoin CLI-rich test, get transaction, this guy. There we go, and we see that there was the 50 input, 50 output, right? So now what we're going to do is we're going to make a new transaction that is replacing this. So let me just decode this so that I can get the information about it. Bitcoin CLI-rich test, decode raw transaction. And then for this guy, we're going to make a new transaction. So Bitcoin CLI-rich test, raw transaction. The input is this one. TXID. And then out 0. There we go. And then we're paying to that same address, this guy, or just go to the top and make sure I got the same one. Here we'll have this one sending to that second address. And this time we're going to do 49.23456. Yeah, 9 and then 5. There we go. Okay. So now the parent has fees on it. And so under normal rules, like pre 0.28, this should properly replace by fee the parent transaction, which would also make the child invalid. So let's try this one out. If I go here, I'm going to sign it and then replace it with replace that with a 0.3. Sorry. Sign transaction with wallet. That guy. And then that is a typo. And replace this with a 0.3. Cool. Okay. So now I got this guy. So now, under normal rules, I should be able to replace by fee. Send raw transaction. There we go. Okay, look at this. Insufficient fee. Rejecting replacement A to, this is the new transaction ID. It's less fees than the conflicting transactions because this one only has this looks like 500 sats in fees versus the 10,000 sats in fees that the previous child had, right? Okay, so what can we do here? Well, what I can do is I can remake the child transaction and then have that child transaction have the same amount of fees, and then do a package replacement where it's the parent and the child now have a combined fee rate that is higher than the package. But I'll actually have less fees on the child this time. All right, so let's do Bitcoin CLI, reg test, decode raw transaction, this guy. Cool. So then here, we're going to do, let me just go back to where I created the raw transaction last time. This guy, that was the last time I did it. But this time, the parent is going to be this new transaction that I did. And it's still going to be 10,000 fees. I'll actually drop this down a little bit. I'll do 8, 9, 9. There you go. So it's 1 sat less in fees. Cool. Okay, so let's do Bitcoin CLI, reg test, sign transaction with wallet. I went down here. I need dash RPC wallet. Sign raw transaction with wallet. This one, replacing it with 03. And then I have to provide the parent information, which is going to be the parent TXID, which is this guy. This has to say TXID, sorry. V out is 0. Okay, and then we also need to pass some more information in. And that is the script pub key, which in this case was this hex. I need quotes around that. And the amount is now 49.999999995. Okay, so that should work. Missing script pub key because I didn't capitalize the K. There we go. Okay, cool. So that is the child transaction. And remember, we cannot just submit this by itself. Send raw transaction. There we go. Missing or spent because the parent doesn't exist yet, right? So we're going to take both of these and then we're going to submit the package and then it will replace the two that are currently in the mempool because the overall fees for that whole package is higher. So let's go back to where we had that first guy. This one. And we're going to do Bitcoin CLI dash reg test dash RPC wallet equals test. Submit package here, and sorry, array of transactions, and the child. There we go. Oh, package RPS failed because I did not increase the fee by enough. Oh, this is actually interesting, right? So you can see here, the package RBF failed. Insufficient anti-DOS fees, rejecting replacement, because I did not increase the fees by enough to do the whole package there, right? So I think that's because I had the 1 Satoshi on the parent transaction. No, that's on the child transaction. That's the 1 Satoshi there. So I can just redo the child transaction for that guy. Okay. That makes sense. So still rules around that. So here, I can just do the 1 Satoshi. Let's just do it like that. Okay. And then we do where I signed the raw transaction. We replace this with the one that has the high enough fees for the child. Okay, which is this guy. Okay, there we go. And then we submit the package. Replace this child with the new child. There we go. Cool. Okay, that worked. So we see that the package message was a success. The transaction results are that these two got put in there. You can see that this one had 500 sats and this one did 19,500 sats. And the effective fee rate was like 0.0001, sorry, 0.0009 for both. And we can see that we replaced the first 2 transactions that we sent. So now if I do Bitcoin CLI, reg test, get mempool, we can see that these were replaced, right? Okay, so that's like package relay there. So the last major feature that was added for 0.28 is anchor outputs. For this final section, we're going to go over pay to anchor outputs, which is a way that you can attach a output to your transaction that doesn't require any witness data to spend. And so we'll just demonstrate that that works. And so this is useful in a bunch of different contexts, like particularly Lightning, right? But for anything where you want to have a child that's specific, an output on your transaction that specifically exists in order for you to fee bump it, right? So what we're going to do is we're going to create a transaction with a pay to anchor output, and then we're just going to burn the pay to anchor output, making a op return transaction, right? So here, let's go. We'll do Bitcoin CLI list dash reg test dash RPC wallet equals test list unspent. Okay, we have some more coins. So we'll use this guy up here for that one. So we'll do Bitcoin here. Oh, and I didn't explain this. So the pay to anchor output, the way that it looks is that you're always paying to this address, which is BCRT1P fees. If you're on mainnet, then it's BC1P fees, like raw GF. This on RegTest, it's NYR2TX, right? And so, and you can see that it identifies it as an anchor output, right? So if you don't have any extra coins, you can just make some more coins for yourself, but I already have a coin right here that I'm going to use. Okay, so we'll do create a new pay to witness script task address to send the pay to witness output to. So let's make a new address. There we go. And then we can do Bitcoin CLI dash transaction txid of this guy is the input. And then the V out on that, because it's a Coinbase, is going to be 0. And then for the outputs, we're going to have one output to this guy. And we'll do 49.99. And then we're going to have one output of 240 sats to the anchor output. Because I did not close this guy. Why is it doing that? Because I didn't start bracket here. There we go. Okay. So take this guy, we sign it with the wallet. Okay, so he's done. So let's take this and send it off. Cool, so now he's in the mempool. And then we're gonna take that paid anchor output, and then we're just gonna make a transaction spending it as a op return, right? But just to show you that it doesn't require any witness data in order to spend. So again, it's like a very lightweight way of attaching output to your transaction that purely exists for you to create a child, which can provide fees and bump it, right? But so let's go here, Bitcoin CLI, bridge test. Let's decode this guy real fast. Yep, you can see here that the second output is this guy. We're just gonna burn all that to fees. So let's do where, sorry. Okay, so we'll just make an op return. Bitcoin CLI dash, oh, sorry, I needed that info. Bitcoin CLI dash reg test dash RPC wallet equals test. We're going to do create raw transaction. We're going to use, oh, oops, sorry, it's this guy. We're going to use the anchor output as the input. And then for the output, going to do an op return for data of fees. There we go. I have to make this parse properly. Oh, it's hex. Sorry. Then okay, so now we're going to create the raw transaction, and we have to put the txid of the parent, the v out of the anchor output. There we go, we create the raw transaction, and here, if we decode this, you can see that there is one input and there is no script sig, but because this is an anchor output, that's actually fine, because there's no script sig required. So let's just try sending that out. Sorry, this actually hit a transaction size too small error. I have to make the op return bigger. There we go. Okay, so we'll send that guy. There we go. Cool. So that guy was sent. So here, if we go get this transaction and look at it, well, we already have it above, basically. You can see that it's because it's spending an anchor output that there's no script sig required. So this is like the smallest way that you can attach a output to a transaction that only exists in order to fee bumping. So when you fee bump it, you only have to do this empty script sig payment for it. So there we go. That's the whole thing. So let me know what you think of this. For future Bitcoin releases, I'll do more of these, but this was interesting making it, and I hope you enjoyed it. Thanks.